Good morning and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing Illustrative Math Grade 8, Unit 8, Lesson 2. Our first question is the warm-up. What do you notice? What do you wonder? Intersecting circles. I see circles that are different colors. B and C seem to be the center of the circles. However, the length BC seems to also be the radius, the distance from the center to the edge of both of the circles. And from A to C is also the radius of this circle, and A to B is also the radius of this circle, which means these lines that are the radius of a circle are also part of this triangle. A line can be part of more than one thing. And because all of these distances are the radius of the circles, that means this has to be an equilateral triangle because all three sides are the same length. Okay, this says use the circle to estimate the area of the square shown here. So we have a circle. How do we find the area of a square? It's the side length squared. Length times width. They're the same distance. You take the length of one side and you square it. How long is each side of this circle, or each side of this square? Well, the side lengths are also the radius of this circle. And what is the radius of this circle? Well, it looks like about 5.5, 5 1/3. So if we go with 5.5, 5 1/3, maybe call it 5.4 squared. Well, what is 5.4 squared? It is 29.16. So if that is our estimate for the area of this square going by the estimate from that radius, our next problem says use the grid to check your answer. So as we've been doing, we can enclose that square. This outer square has a height of 7. From -2 to 5, that's also 7. 7 squared is 49. Now, what is the area of each of these four outer squares? Well, that goes from 0 to 5. Height of 2. 5 times 2 is 10. 10 over 2 is 5. 5, 10, 15, 20. The area of those four outer ones is 20. (49) subtract 20 is 29. So the area of that square is 29 square units. Our estimate was 29.16, so that was close, but that means that the side length of this is not exactly 5.4. Our next "Are you ready for more" problem. One vertex of the equilateral triangle is in the center of the square and one vertex of the square is in the center of the equilateral triangle. What is x? So now we need to figure out the angle x. Well, what do we know? We know that if this point is in the center and this point is in the center, we know that this angle and this angle have to be congruent to each other. They have to be the same angle. And an equilateral triangle, we know that all the angles of an equilateral triangle are 60 degrees. So if this angle is 60, each side of this angle here has to be 30 degrees. Similarly, we know that this angle is 90 degrees, which means each half of it has to be 45 degrees. So, if this angle is 45 degrees and this angle is 30 degrees, these two angles combined are 75 degrees. And we know the angle sum of a triangle, because this shape here is a triangle, the angle sum is 180 degrees. So if we do 180 degrees, subtract 75, that is 105 degrees. So the measurement of angle x is 105 degrees. Okay, find the area of each square and estimate the side lengths using your geometry toolkit. Then write the exact length for the sides of each square. So, these squares, if we enclose this one, not the best job I've ever done right there, but this has a height of 1, 2, 3, 4, 5, 6, 7, which means that outer square is 49 units. These inner triangles are 1, 2, 3, 4, 5 by 2. 5 times 2 is 10, over 2 is 5. There are 4 of them. 20 units. This is the same as the triangle we did a minute ago. 29 units squared. The area of square A is 29 units squared. Triangle B we enclose it, is 6 by 6, so that is 36 square units. These triangles on the outside are 3 by 3. 3 times 3 is 9, over 2 is 4.5. 4.5 times 1, 2, 3, 4 is 18. 36 subtract 18. Let me move that up so you can see better. Sorry about that. 36 subtract 18 is 18. So the area of square B is 18 square units. Square C is enclosed in a 5 by 5 square. 5 times 5 is 25. These outer triangles are 3 units by 2 units. 3 times 2 is 6. Over 2 is 3. So the outer area is 3, 6, 9, 12. 12 units. 25 subtract 12 12 is 13, so square C has an area of 13 square units. Now, if we want to know the exact side lengths of these, we could try measuring them, or we could try finding out what you multiply by itself to get these areas. So what number do you multiply by itself to get 29? Well, it's more than 5 because 5 squared is 25. It's less than 6. So it's because this is less than 36. From our first problem, we saw that the side length is approximately 5.4. But if we want to be more accurate with this, we need to find the square root of 29. The square root symbol looks similar to a division symbol. On your calculator, it will be usually right where the squared button is. And on your calculator, one thing to remember is we do not type in 29 and then the square root button. We have to type in the square root button and then 29. What this will actually look like on your calculator when you type it in is the calculator gives you the square root symbol and then an opening parenthesis. So on your calculator, you can type in 29 and the square root of 29 is 5.38. You'll see on your calculator quite a few extra digits. We don't always need to write down all of those digits. We will spend some more time in the future going over exactly how to handle that. Okay, our next one, the area is 18, so we want to know the square root of 18, which is 4.24. And then our last one on here, we want to know the square root of 13, which is 3.6. Now this says to write the exact side lengths. If we want to be exact, each of these gave us extra decimals. One practice that we are going to start doing is the exact side length of this square is the square root of 29. The exact side length of this square is the square root of 18. And the exact side length of this square is the square root of 13. This is one of those situations where you get to do what I call being lazy, and instead of calculating it, you can leave this value, you can leave this length as the square root of 29, the square root of 18, the square root of 13. Our next question gives us a table of values, and it says complete the table with the missing side lengths and areas. Well, if the side length is 0.5, if the side length is 1/2, 1/2, the area is 0.5 squared. 1/2 times 1/2 is 1/4, or 0.25. 1.5 squared is 2.25. 2.5 squared is 6.25. 3.5 squared is 12.25. Now, some of these go the other way, and fortunately they're all nice values. The area is 1. What is the side length? Meaning, what is the square root of 1? What do you multiply by itself to get 1? That's just 1. What do you multiply by itself to get 4? 2. What do you multiply by itself to get 9? 3. What do you multiply by itself to get 16? 4. Let's continue through the table here with side lengths. 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 4.5 squared is 20.25, 5.5 squared is 30.25, 6.5 squared is 42.25, 7.5 squared is 56.25. Okay, we have a nice table of values. Now it says to plot the points S, comma A, so side length, comma area, on the coordinate plane. So 0.5, 0.25. If this is 2, this is 1. 0.5 is going to be here. 1, 1. 1.5, 2.25, 2 goes with 4. 2.5 goes with 6.25. 3 goes with 9. Okay, I will pause this while I finish putting these points on the table. Okay, I plotted all those points. There are not room for all of them. This goes up to 749. Use this graph to estimate the side lengths of the squares in the first question. We already did those exactly. Use the graph to approximate the square root of 45. Well, to approximate the square root of 45, we look at 45. Our line would be approximately here. So 45 would be 6.8-ish. I should have moved this so you could see better. Use the graph to approximate the square root of 45. That should be approximately 6.8. Our summary. We saw earlier that the area of square ABCD is 73 units. What's the side length? The area is between 8 squared and 9 squared, so the side length must be between 8 units and 9 units. We can use tracing paper to trace a side length compared to the grid, which also shows the side length is between 8 and 9 units, but we want to be able to talk about its exact length. In order to write the side length of a square whose area is 73 units, we use the square root symbol. The square root of 73 is written the square root of 73, and it means the length of a side of a square whose area is 73 square units. We say the side length of a square with area 73 square units is the square root of 73 units. All of these statements are also true. The square root of 9 is 3 because 3 squared is 9. The square root of 16 is 4 because 4 squared is 16. The square root of 10 units is the side length of a square whose area is 10 units squared. And the square root of 10 squared is 10. Squaring and square root are inverse operations. Much like adding and subtracting cancel out, multiplying and dividing cancel out, squaring and square rooting will cancel out. The square root of 10 squared will be 10. Okay, this has been another episode of Mr. Boskin Does Some Math. Thank you for tuning in. See you next time.